Alright, exercise A under measurement. Question 7. Our statement, let's read the statement. A concrete gate post comprises a right rectangular prism having a square base and a pyramid at the top, as shown in the diagram here that we are given. The length of the sides of the base is 30 centimeters. We have 30 centimeters, 30 centimeters, and the other two sides. And the height of the rectangular section, the height of the rectangular section is 150 centimeters. So on the post, we have this rectangular section, which is having the height of 150 centimeters, and the perpendicular height of the pyramid section, this is our pyramid section, this is our pyramid section on top of the rectangular section, and the height of the pyramid is 8 centimeters. Alright, and then in a box here we are given the formulas for number 1, volume of a pyramid is equals to 1/3 area of a base multiplied by the height, and we also have the formula for the total surface area of a pyramid, which is given by area of the base of the pyramid plus half multiplied by perimeter of the base of the pyramid multiplied by the slant height. Alright, now question 7.1, we have to calculate the volume of the concrete required to make one post. We need to calculate the volume of the concrete to make a post. Alright, we say volume of concrete to make one post will be equals to the volume of the rectangular prism plus the volume of the pyramid. Remember, our post is comprised of what? Of a right rectangular prism as well as a right pyramid. Therefore, this will be equals to, now what is the volume of a prism? Our rectangular prism, the volume will be area of a base multiplied by height. Base 30 multiplied by 30, 30 multiplied by 30, area of a base multiplied by the height of the prism 150 centimeters, 150 plus volume of a pyramid, volume of a pyramid, we're given the formula there. Volume of a pyramid, 1/3 of area of a base. The base of the pyramid, 30 centimeters, and the other two sides. Therefore, area of a pyramid, area of a base of a pyramid, 30 multiplied by 30 and multiplied by the height of the pyramid. We are given the height of the pyramid here as 8 centimeters, and this will be equals to, using your calculator, you should get your volume as 137400 centimeters cubed. This will be the volume of a concrete to make one post. 7.2, we have to calculate the surface area of the pyramid section of the post. The pyramid section of the post. Now, this is our pyramid section. You know that for you to be able to calculate the area of a pyramid section, we need the slant height. We need the slant height. So how do we calculate the slant height? So I'm just going to make some construction so that we can try to visualize what we are actually given. So let's say this is our perpendicular height and it goes to this side, and this is an angle of 90 degrees. So what do we have? Let's say this point here, let's say it's point A. Let's say it's point A, and then at the apex there, let's say it's point B, and then this point, let's say it is C. Now what is the slant height? The slant height is actually what? BC. BC will be our slant height. Therefore, you will see that ABC forms a right-angled triangle, and we know the length of AB, which is equals to 8 centimeters, and we also know the length of AC. AC will be what? Half the length of the base, meaning AC will be equals to 15. Therefore, we can calculate BC using what? Theorem of Pythagoras. BC is our hypotenuse, which is the slant height. So let us use, or let's just say, slant height squared will be equals to AB squared, which will be 8 squared, plus AC squared, which will be 15 squared. And then we have our slant height equals to, we are now going to take the square root on both sides. It will be the square root of 8 squared plus 15 squared is 289. Then the square root of 289 is equals to 17. Therefore, our slant height will be 17 centimeters. So now we are ready now to can calculate the surface area of the pyramid section. Then we can now say surface area will be equals to, let's start first with the what? With the surface area of a pyramid. The surface area of a pyramid is given by base area plus a half multiplied by base perimeter multiplied by slant height. I'll just use small letter s to represent slant height. This is the formula that we're given here. But now, the question does not want us, in fact, yes, the question does want us to calculate the what? The area of a pyramid section. But the question is, are we going to calculate the area for the base? And the answer is no. Remember our pyramid section. This is our pyramid section. Our pyramid section, we cannot touch its base. So the only surface area that we are going to calculate, it will be the surface area of the of the lateral sides. Therefore, it means what? Our formula for the surface area for question 7.2 is just going to simplify will be simplified to just half multiplied by base perimeter multiplied by the slant height. Half multiplied by base perimeter multiplied by the slant height, which will be equals to half multiplied by our base perimeter. The perimeter of the base 30 plus 30 plus 30 plus 30. We're adding 30 4 times. Therefore 30 multiplied by 4 multiplied by our slant height. We have calculated our slant height as 17 centimeters. Therefore this will be equals to now half multiplied by 30 multiplied by 4 multiplied by 17. Then this gives us 1020 centimeters squared, and this will be our surface area of the pyramid section of the post. And then question 7.3. Question 7.3, if the length of the sides of the base is halved, how many posts having the same design as the original can be made with the same volume of concrete as the original post? Right. The length of the sides of the base is halved. So what will be the new volume? We start there to say what will be the new volume. One way of doing it is to just halve the sides of the base. Remember, the sides of the base, they are each 30 centimeters long. Therefore half of 30 centimeters will be 15. Then what do? You go back to 7.1, and then now where we have 30, you just have 15, 15, 15, 15. That is one way of doing it, and then you get the new volume. Or you can just say we are halving the base, the sides of the base, half, and then we are going to square. Remember, when we're dealing with the scale factors, with the volume, if it is all the dimensions, then we are going to cube the scale factor. But this time around, we are not dealing with all the dimension, meaning the length, the breadth, and the height. It's only the length and the breadth. Hence, we are going to square it. Multiplied by the original volume. What is the original volume? We calculated the original volume in 7.1. 137400. 137400 is equals to, now what will be the new volume? What will be the new volume? 1/2 squared times 137400. Then this gives us 34350 centimeters cubed will be the new volume. Now the question is now, how many posts can we now have such that the volume of the total number of those posts will be equal to the volume of the original post. The original post, the volume is 137400. Now the new volume is now 34350. So the question actually is the volume, the original volume can take how many of the new volume. Therefore we are dealing with division. Therefore we are saying number of posts will be equals to the original volume 137400. So the question is, in 137400, how many of the new volume are we going to have? the new volume 34350, which will be equals to then 137400 divided by 34350 will give us 4. Therefore, we are going to have what? 4 posts. Meaning, we are going to have 4 posts that are having a volume of 34350. Because 34350 multiplied by 4 will give us the original volume of 137400. Now moving to exercise B. Exercise B, the diagram below shows a cup with a volume of 117 pi centimeter cubed and an inner diameter of 60 millimeters. Ignore the thickness of the cup. And here we are showing the cup. Already you should realize that here we are dealing with the cylinder. Now 6.1, we have to calculate the height of the cup. We have the volume, we have the diameter. We have to calculate the height of the cup. So firstly, let's use the volume of a cylinder. Volume of a cylinder is given by 2 this is the surface area. Volume of a cylinder is given by pi r squared h, pi r squared times h. But now our dimensions, the volume, it is in centimeters cubed, and the diameter, it is in 60 millimeters. So we must ensure that we are working with the same units. So it's very important for you to note that the diameter, convert the units of a diameter to centimeters. The diameter, 60 millimeters divided by 10 will give us 6 centimeters. So the diameter in centimeters will be 6 centimeters. So now let's substitute our volume. 117 pi is equals to pi r, which is the radius. The radius will be the diameter divided by 2. Diameter is 6, the radius will be 3. 3 squared multiplied by the height. And then we are going to divide both sides by pi 3 squared, or 9 pi. Then we get 117 pi divided by pi times 3 squared gives us 13. 13 is equals to h. Therefore, the height of the cup will be equals to 13 centimeters. Now question 6.2, we have to calculate the total surface area of the water that touches the cup if the cup is 80% full with water. So firstly, the total surface area of a cylinder is given by 2 pi r squared plus 2 pi r h, where 2 pi r squared will be pi r squared of the base and pi r squared of the top. Pi r squared plus pi r squared, 2 pi r squared. And our 2 pi r h will be the sides of the cylinder. Now, going back to our question, we only need the surface area of the water that touches the cup. So let's look at the picture here of the cup. It's clear that the surface area of the water that will touch the cup, it is the one at the bottom. Therefore, the one at the top does not touch the cup. Therefore, instead of having 2 pi r squared, we are only going to have 1 pi r squared, because the surface area of the water that touches the cup, it's only the one at the bottom, not the top. Then on 2 pi rh, we are also told that or rather yes, we are told that we only need to calculate the surface area of the water that touches the cup if the cup is 80% full with water. The cup is not filled to the top, but it's only 80% filled with water. Therefore, it means what? The height is going to be affected. We only need 80% of the height. Therefore, 2 pi rh will now become 2 pi r multiplied by h times 80%. 80%, 80 divided by 100, 0.8. Therefore, our formula becomes the formula for calculating the surface area of the water that touches the cup if the cup is 80% full of water will be pi r squared plus 2 pi r times h times 0.8. Then let's substitute pi times our radius 3 squared plus 2 times pi times our radius 3 times h, which is our height. We have calculated in question 6.1 is 13 centimeters times 0.8. Then this will be equals to, use your calculator, pi times 3 squared plus 2 times pi times 3 times 13 times 0.8, and this will give us as a decimal, this will give us 224.31 centimeters squared.